Hello and good afternoon, CTS110 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CompTIA Net Plus course, and this afternoon's video tutorial is going to be a review and solution set here for worksheet number 8, where we took a look at IPv4 subnetting one more time. Again, can't stress enough the importance that a thorough and deep understanding of IPv4 subnetting is going to serve you well when you go to sit to take the CompTIA Net Plus exam. So we take a look here at chart 1, and let's talk about chart 1 right out of the gate. And this is really sort of a straightforward conversation about how many subnets do I need, right? So if you're told you need a certain number of subnets, how can you figure that out? Well, remember that the number of subnets is 2 raised to the number of borrowed bits. So if we're talking about a default subnet mask of /24, when I go to borrow the first bit right here, I'm turning that into a /25. And again, that's the classless inner domain routing notation, or the CIDR notation that represents the dotted decimal notation 255, 255, 255, 128. Now that first borrowed bit is giving me 2 to the 1 because I've borrowed 1 bit from the host bits. So 2 to the 1 is 2. If I borrow 2 bits, 2 to the 2 is 4. If I borrow 3 bits, 2 to the 3 is 8, and that's the number of subnets that I'm creating. So a /25 is going to give me 2 subnets. A /26 is going to give me 4. A /27 gives me 8. And you'll notice that there's an inverse relationship. As the number of subnets increases, the number of host bits, and therefore the number of usable host IPs, is going to decrease. So /28, when we borrow 4 bits, we get 16 subnets. When we borrow 5 of those host bits, we get a /29, and we get 32 subnets. And then finally a /30 is going to result in 64 subnets. However, a /30, we are only going to have 2 usable IP addresses, right? So tiny networks, typically only for point-to-point links. So the question is, how many subnets do I need? As soon as you sort that answer out, all you need to do is start to borrow the host bits and then do the calculation to give you the subnet mask. You'll know the CIDR notation, and then you'll end up with the number of subnets. So if I said you needed to have at least 10 subnets, what would you choose? You have at least 10, but as close to 10 as you can get, but meeting the requirement that you had 10. You would choose 2 to the 4, because that gives me 16. That's as close as I can get to 10 without being under 10. If you said 2 to the 3, you'd only get 8, so you'd be short 2. So 16 would be the correct answer. If I said you needed to have 29 subnets, what would you choose? Exactly. You would borrow 5 bits, and you would have 32 subnets. And so this is an easy way to figure out, okay, if I need 4 subnets, what would I pick? Well, 2 raised to the what is going to give me the closest number greater than or equal to the number of subnets that I'm looking for. All right, let's go ahead and clear that off here. Let's come down to the second chart again for a quick review. Chart number 2, how many hosts do I need? And again, remember, these are 2 questions that are definitely related. How many subnets do I need? How many hosts do I need? But we're talking about basic Class C networking here. So again, the number of usable, or you'll see it referred to as valid host IPs. This is code for usable IP addresses. Well, with 2 hosts, we take that 2, if I only needed 2 hosts, it would be 2 to the 2. So how do I know what this 2 represents? Again, Same thing as it did in the other equation, but it's the number of host bits, not the number of networking bits, the number of host bits. I should say the number of subnet bits right here. So how many host bits are left over? Well, 2 to the 2 is 4, minus 2 is 2. So if I need at least 6 host IPs, I know that 2 to the 3 minus 2 is 6. So I need to make sure I have at least 3 host bits left. What if I have 4 host bits left? Well, that's going to give me 14 hosts. 5 host bits is going to give me 30 hosts. 6 host bits, 62 hosts. 7 host bits, 126 hosts. So to answer this question, when you're asked, or when you realize, hey, I need to have at least 60 host addresses, you simply have to take a look and say, okay, I know 2 to the 2, 3, 4, and 5, those are less than 60, but what about 2 to the 6? Well, 2 to the 6 is 64, minus 2, and remember, that minus 2 is for what? It is for the subnet ID and the broadcast address, or I'll just put bcast here, and the bcast address, right? The broadcast address. So again, when we take a look at the subnet bits, let me ask you this. So this right here, it's a /28. We've borrowed 4 bits. So how many subnets am I creating there? Well, 2 to the 4 is equal to 16. So I've created 16 subnets, and inside each of those 16 subnets, how many IP addresses, how many valid hosts or host IPs or usable IPs will there be? So 2 to the 4 minus 2. So 16 minus 2 is 14. So if I used a 255, 255, 255, 240, or in other words, a /28, I would have 16 subnets, and inside each of those 16 networks, those subnets, each would have a maximum of 14 usable host IP addresses. All right, let's go ahead and clear our screen here, and let's scoot down a little bit. So now we come to complete the subnetting information. So what are we presented with here? Well, we have a Class C IP address, 210.100.25.0. So that is our network that we're dealing with. So by default, it is a /24. So it says Class C default mask in binary. Well, what is the default mask in binary going to be? Well, remember the first 24 bits, 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8, dot, 1, 2, 3, 4, 5, 6, 7, 8. So if we know it's a /24, the first 24 bits, each of the first 3 octets, will all have the 1 value on for the default mask. Now, this says build the new subnet mask, so you have 30 host addresses in each subnet. So with this requirement, it's pretty easy, right? So I need to make sure I have at least 30 usable or 30 valid host IPs in the subnet. Well, 2 raised to what is going to be greater than or equal to 30? Or I should say greater than or equal to 32, because we have those 2 addresses. So the step right here says build the 4th octet from right to the left with zeros. So I know that I need to have 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32. And so then we would have 6, 7, 8. And as you can see, it kind of matches up with what's down here. But again, 2 to the 1 is 2, 4, whoops, not drawing again, 8, 16, and 32. So we know that we need to have at least 5 host bits remaining. So that gives me a /24, 25, 26, a /27 will meet this requirement. So Again, the new subnet mask in binary would be 1234567 dot 1234567 dot 1234567 dot 123 1 2 3 4 and 5. So it says highlight the rightmost one in the binary mask. So that is the rightmost one. So 128, 64, and 32. And that is our block size. And that's when you yell bingo. Because as soon as you get that block size, it's kind of game over. So it says the decimal value that is, the decimal value of that bit is the block size. Well, it's 32, which means my subnets will start with subnet IDs of .0, .32, .64, .96, .128, .160, .192, .224, and then if I added 32, I would get 256, which is over 255. So we are done. 255, 223, 191, 159, 127, 95. These are the broadcast addresses I'm filling in here at the bottom. And I'm sorry, .31, and that should be 63. All right, so there are your networks. And you should have how many networks? 2 to the 3 is 8. So there's network 1, 2, 3, 4, 5, 6, 7, and 8. So that is it. So the new subnet mask in decimal, and again, those are the subnet bits right there. It's going to be 255.255.255, and I'm quickly running out of space here. So what is 128 and 64 and 32? 224. And that is my /27. All right. So that takes care of that. Let's go ahead. I think we need to roll down just a little bit more here. And is that asking 210-100? Hold on one second. Was that the same? Yeah, 210-125. So we actually filled in all this information already. So the new subnet mask creates 8 subnets. Each subnet has 30 possible hosts. And if we were to fill, we could actually fill this in without even having to figure it out again. So remember, it was going to be the subnet address, then .32, .64, .96, .128, .160, .192, .224. So the valid host IPs would be .1, and we'll get the broadcast address in here again, .31, .63, .95, .127, .159, .191, .223, and always last .255. So .1 to .30, .33 to .62, .65 to .94, .97 to .126, .129 to .158, .161 to .190, and again, these are all the usable host IPs in each of the individual subnets, .222, and then .225 to .254. All right, so let's go ahead and clear that, and we'll come over here. I believe that was the end of the worksheet. We've got a little variable mask subnet length here. Let's see what we've got. Okay. So we talked about VLSM, or Variable Length Subnet Masking. And remember, what that is inside of the same network using different length subnet masks. So we take a large, for example, a /24, and maybe we create a couple /30s. maybe and then in addition, a /29, and then a /28, maybe a /27. So we've got variable length subnet masks that we've incorporated into a larger, and we've carved up a larger network. So for example, one subnet needs 120 hosts, another needs 60, and two others need 28. You simply create different length subnet masks for those networks. So let's take a look here. So the only IP address not listed on the chart below are the broadcast addresses. So we start with that as our subnet, and we create a /25. We borrow a single host bit from the 8 host bits that existed by default for a Class C address. And again, 192.168 is a Class C address. So the block is going to be 128, which means that from 1 to 126 are going to be our usables. 127 is going to be the broadcast address, so it's not listed. So I create this first network, and then let's say my boss comes to me and he says, hey, I think that's great, right? We did the HR. Let's say this is our HR department here. So HR needed to have at least 120 usable IPs. So we did a /25. Well, now I'm bringing in the engineering department. So the engineering department, I want them to use a network in that same space, because maybe that's the only space that we've been given. So we already carved up half of it. Now I need at least 60 usable host addresses. So what can you do for me? Well, we're going to start at remember the block size for the first allocation was 128. So we go from .0 to .128, with .127 being the broadcast address. So the next network ID will start at 128. But I'm not using another 128, right? I'm using 60. Or I'm looking for 60 usable host IPs. Well, I know that to get that, I have to have at least 6 host bits. So I can get away with only borrowing 2 of the host bits, leaving me with 1, 2, 3, 4, 5, 6. So 2 to the 6 is 64, minus 2, I'm sorry, minus 2 is 60, and that meets the or 62, which meets the requirement of having 60 usable host IPs. But again, this is a /26. And right there is your variable length subnet mask inside of a larger classful /24 subnet. So now the block size is 64, which means from 128, we would go to the next block size of 64. We add it to that. We get what? What is that? 192. So 192 would be the next network ID in line, which means my broadcast would be 191. So there is network 2. So now your boss comes back to you and he says, hey, listen, I need another network with 28 hosts, right? So we say, okay, we know what the network ID is going to be. To get to 28 hosts, I'd have to be at least 2 to the 5, which would give me 32, minus 2 is going to give me 30 usable host IPs. Well, what is the block size of a /27? We know that that's 128, 64, and then 32 is the block size. So if I add 32, and give me a second here, host needed 32. Oh yeah, sorry. 224. There we go. Just having some mathematical issues in my head there. So the default gate, or I'm sorry, the broadcast address is going to be 223, right? So here is my network. And then your boss comes back and says, hey, we need another /27. Maybe that's going to be marketing, and maybe this is going to be shipping and receiving. So give me another /27. And I need at least 28 usable IPs. And you say, hey, you know what? That's our last available subnet, right? But here it is, and that takes us to 255. So there are your 4 networks, and you can clearly see inside that larger /24, we used a /25, a 26, and 2 27s. And that is what variable length subnet masking is all about. When you're using variable subnet masks of variable length all inside of a larger subnet. All right. So let's clear that off here, and I think we're going to have an opportunity here. So here we go, right? So here is our opportunity. Your organization needs subnets for the following number of hosts. So we can see here we're going to need at least how many subnets? 2, 3, and 4. So we know that from the subnet perspective, 2 to the 2 equals 4. So if I borrow 2 of the host bits out of a /24, that's going to make it a /26. Right? Now, we know that that's how many subnets we need, but more importantly, we need to meet this address requirement here. So 120 hosts. 2 to the 7 would be 128. Minus 2 is going to be 126 usable. So 2 to the 7 is what we're looking for. So we need to have at least 7 host bits. Well, if there's 7 host bits in the last octet, how many bits are left for subnet bits? You've got it, just 1. So 2 to the 7 minus 2 equals 126. That gives us a /25, right? Because there's only 2 to the 1 subnet bits that are there. And 2 to the 1 equals 2. So we've created 2 subnets. Again, we're only going to use one of those subnets, and it's going to be the first one right here. So as you can see, there is our /25. The mask in binary, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. First 25 bits will be on. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then that, and then 1, 2, 3, 4, 5, 6, 7. Now my block size here is 128. I know that that's my block size because that is the rightmost subnet bit. Available hosts will be 126. Hosts needed 120. So what is my range? Well, it's going to be from .1 to .127. And actually, that is wrong. It's going to be 1 to .120. So we're going to have .0, .128, 127, 126. Actually, let me just rewrite that whole thing right there. .126. So that's my range. But the block size is 128, which means I'm using the first network here, right? So the next network will start from .128 inside of this 200.5.5.0 class C network. So we have to start at .128 for the next one. Well, now I need 55 hosts. So I know that 2 to the 5 is 32. That's going to be way short. 2 to the 6 is 64, right? Minus 2 is 62. That's going to meet my requirement. So I know that 6 of the last 6 bits are going to need to be 0. So let's write this: 2, 3, 4, 5, 6, 7, 8. .1, 2, 3, 4, 5, 6, 7, 8. .1, 2, 3, 4, 5, 6, 7, 8. .1, 2, because the last 6 bits have to be host bits. So my block size is going to be 64, which means the available hosts are going to be 62, right? 2 to the 6 minus 2, and we meet that requirement. So the subnet ID would be 200.5.5.128, right? Remember, that's the next network we need to use. The block size is 64, so 128 plus 64 is what? 192, which means the broadcast address will be 191 for this network. So this is network number 1, network number 2. And now we know that network number 3, when we figure out The block size, it's going to start at 192. So my usable IPs are going to be from .129 up to .190, right? With 191 being the broadcast address. So then we're left with 25 and 22 hosts. We should quickly recognize those are /27s. Very similar to the previous exercise. So the next network, we already know what that's going to be. 200.5.5.192. And if the block size again for 27, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3. So the first 27 bits are all network bits. We've got 3 that we've borrowed. That means the last 5 bits are going to be my host bits. So 2 to the 5 minus 2 is going to be 30. Meets my requirement in both locations. And then what is the block size? Well, the block size would simply be the value of the rightmost subnet bit. So 32 and then 32. So I can actually figure out now that 224 is going to be that other network, which means 223 is the broadcast address for this guy, and .255, which is the last available numeric value, will be the broadcast address there. So 193 is the first usable all the way up to 222, and then here it's going to be .225 all the way up to .254. And again, that would be the same in binary. And here we would have 200.5.5.224. And all right, so that's going to wrap up worksheet number 8. And again, this has been about variable length subnet masking, where we take a larger network, right, at a classful boundary, and then subnet that network using variable, right, variable length subnet masks. So we took what was a /24 and carved it up into 1/25, 1/26, and 2/27s. All right. Well, thank you guys so much for watching, and I will see you on Tuesday evening. Have a great night and enjoy the rest of your weekend.